I'd like to just introduce our final speaker of the day, our keynote speaker. When I was speaking with her on the phone back in March for our original event schedule, she threw out a phrase that really intrigued me, which was open access oceans. I had never thought of open access for an entire ecosystem of the natural world, so I was quite intrigued by that. Her organization which is called the Hydrous, uses VR and 3D printing to bring marine environments into people's lives in ways so compelling that they want to engage in solutions to the threats to these environments. Erika Woolsey is, for her, the entire marine environment is an ecological collection. And as we move forward, all of us, in putting our digital collection, our digitized collections out there in a more impactful way, the Hydrous reminds us that, quote, data sets don't spark an emotional investment, right? We have to make an emotional connection to what we do if we want to achieve greater impact. Erika believes that a human connection to nature can change the world. She's a coral reef ecologist who's been exploring coral reefs around the world for over 15 years. She conducted her PhD research on the Great Barrier Reef, where she investigated the effects of warming temperatures on coral health. As a CEO and co-founder of the Hydrous, a nonprofit based in San Francisco, she uses science, design, technology, and education to demonstrate why marine environments are worth protecting. So please join me in welcoming Dr. Erika Woolsey.
Thank you, Diane, and thank you to the Digitization Program Office here at the Smithsonian for putting this incredible event together, especially twice in 1 year. I'm learning a lot, and there's much to discuss and to think about. So I've really been enjoying this, and it's a pleasure to be here. So I'm a marine biologist with a specialty in coral reefs, and I've been lucky enough to travel the world exploring these miraculous ecosystems. Unfortunately, many of the places that I've been studying have changed dramatically in a very short period of time. And ocean environments in general are overexploited, underprotected, and out of mind. So that's why my nonprofit, the Hydrous, is working to bridge the disconnection between scientific discovery and public understanding. And today I'll be telling you about our approach of digitizing and sharing coral reefs to increase ocean literacy and inspire protection. So besides the beauty and wonder of our oceans, why should we care about them? Well, it turns out the oceans are crucial for the health of our planet and the survival of humans. We live on a blue planet. The ocean covers most of our Earth, provides more than half of the oxygen we breathe, and that's in our atmosphere. And the ocean also drives economies. If the ocean were a country, it would have the world's 7th largest economy. And yet it doesn't have a seat at the G7, the WTO, or the UN. Coral reefs specifically provide food and livelihoods for hundreds of millions of people around the world, protect shorelines from erosion, and house about 25% of all marine biodiversity. They're truly the rainforests of the ocean. And unfortunately, ocean health is rapidly degrading. Most fishing stocks are overexploited, and we've lost about half of our shallow water coral reefs in just the last few decades. The large-scale global pressures that are causing this crisis are mainly due to a surplus of carbon dioxide in our atmosphere, which is leading to higher than normal temperatures, ocean acidification, and sea level rise. The local and more direct human impacts include unsustainable fishing practices, pollution, and habitat destruction. And the combination and scale of all of these things at once makes it very hard for marine environments to persevere in a changing ocean and recover from disturbances. So you may have heard of something called coral bleaching. The past couple years especially, we've seen mass coral bleachings throughout the globe. And last year, 30% of the Great Barrier Reef bleached. And just for reference, 30% of the Great Barrier Reef is an area about the size of Pennsylvania. And that's where I conducted my PhD research, and it was incredible. By the time I submitted my thesis and moved back to California, a lot of the reef had died, and a lot of the places I had come to know had died. And so bleaching is when the coral animal, which is clear and soft-bodied, much like its jellyfish cousin, expels their algal symbionts that live in their tissues and convert sunlight into energy that the coral needs to survive. And so once those algal symbionts, also called zooxanthellae, are gone, you can see through the clear coral animal to the white skeleton, hence why it's called bleaching. Now, a bleached reef is not a dead reef. It's more like a starving reef, but it leads to high rates of mortality. So here's footage I took at the same reef in Japan before and after a bleaching event. Notice the colorful living coral on the left compared to the dead skeletons on the right that are muted and covered in algae. And I also should mention, this is not just about the coral animals or the reef. These environments support tremendous amount of biodiversity, from the smallest shrimp and nudibranch and sea stars to fish and turtles and dolphins and sharks. And corals are like the trees in the forest. They provide the habitat and the structure. And they basically convert seawater into rock to build these reef systems. I mean, it's miraculous. And I also want you to know that coral reefs can recover from these events. But lately, these catastrophic events are just happening more and more regularly, that the environments don't have the adequate time to make a full recovery before being hit again. So the good news is we know what to do. To reverse the degradation of our underwater Earth, we must curb global emissions, encourage sustainable fishing practices, reduce pollution, and strategically instate, expand, and enforce a worldwide network of marine protected areas, which is what Sylvia Earle calls hope spots. So the big question, which I started to ask more and more as I progressed in my academic career, is why is there this disconnect between the knowledge we have and our actions? We have so much clear evidence of the importance of our ocean, its ongoing destruction, and the solutions, yet the science does not easily translate into public understanding and action. And I'm sure many of you have ideas of reasons for this. The one I'd like to touch on is when it comes to climate science, human impacts, and the biological response, the general scientific output, though it is so important, is just not powerful or accessible to the average person. I should note that all of those figures were from my own publication, so I'm not picking on anyone. We need these data to stand up for facts. But because people generally make decisions based on emotions rather than rational thought, perhaps the goal should not be to convince, but to connect. So this challenge and call to action led me to the Hydrous. My co-founders and I wanted to incorporate the human component into marine science and to generate emotional connections to ocean environments. The mission of the Hydrous is to create what we call open access oceans so that all people may explore, understand, and engage with marine environments which are severely threatened by climate change and more direct human impacts. Of course, the biggest challenge when it comes to ocean conservation is out of sight, out of mind. I mean, how do we care about something we never see or experience? And this challenge is especially important because the things we do on land and the decisions we make every day are affecting the health of our oceans around the world. So my favorite example of overcoming this out of sight, out of mind dilemma comes from Yosemite. I was amazed to learn that the first non-native settlers of Yosemite Valley in the 1850s were artists. And it was their beautiful imagery that traveled the country and captured the public's imagination and was even displayed here in Washington, D.C., including at the White House. And based on what I've read, these artworks created support and led to the signing of legislation by Abraham Lincoln in 1864 to protect Yosemite Valley as the country's first ever wildlife preserve. It wasn't until about 40 years later that naturalist and visionary John Muir convinced President Teddy Roosevelt to expand Yosemite National Park, which led to the creation of the National Park Service. So this Yosemite story is an example, a terrestrial example, of how artists, communities, and leaders can use the tools available, in this case, paintings and storytelling, to share images of natural beauty and conserve biodiversity. Of course, there are many contemporary examples and marine examples of how impassioned individuals use creative means to generate public support and protect natural spaces. For example, the recent expansion of the Papahanaumokuakea National Monument in Hawaii. So when it really comes down to it, change in conservation stems from human connection. People have to care about these natural spaces. And our tools have changed. Now we have the technologies to overcome the natural barriers between us and the ocean. And we have scuba diving, underwater photography, new methods of ocean exploration, reality capture and 3D imaging, virtual reality. We can't bring everyone to the ocean, though I am trying in my own small way. So we're using these tools to bring the ocean to everyone. At the Hydrous, we're working to generate positive impact with digitization and visualizations through our projects in reality capture, expeditions around the world, and electronic immersion through virtual reality. So when the Hydrous first began, it became known for reality capture of coral reefs. We use the method of photogrammetry, which is when multiple photographs of a place or an object are stitched together and a 3D model is generated. And this model can be measured. These models are very data-rich with things like volume and surface area, which are ecologically important information. And you can even compare growth among time points, as Brian Matthews pointed out earlier today. And this model can also be 3D printed. And I've already alluded to the fact that the three-dimensional structure and complexity of a coral reef is a vital part of this habitat. However, traditional monitoring has used two-dimensional methods like tape measures and rugosity chains to collect 3D information. This is like looking at the silhouette of my face to try to understand my expression. It doesn't give you all that information. So Hydrous co-founder Sly Lee, who is working as a marine scientist in Hawaii, began monitoring coral reefs by creating 3D models through photogrammetry. You can see all these gray rectangles show where the photographs were taken. And the Hydrous has created 3D models of individual coral colonies all over the world, including larger sections of reef, like this one. This is about 10 meters by 10 meters. And this is a great way to document and measure coral reef complexity, growth, and health in a non-destructive, in situ way. So 3D modeling has therefore been an important advancement for understanding ocean environments. In the past decade especially, ongoing research is using AUVs and ROVs, as well as DSLRs and even GoPros, to conduct 3D data collection systematically and on a large scale. the Hydrous takes this 3D modeling a step further into engagement and education. Not only are the digital and actual models beautiful, the story of how they were collected is quite interesting. I mean, they're representations of a living coral animal that is still alive on the reef. At least we hope it is. And we found that these visualizations are powerful in starting conversations related to ocean science, coral biology, and marine conservation when we bring them to our public lectures, our science conferences, into classrooms, and we've even had them displayed in art galleries. And here's a model that's about a foot across, and it was painted by a scientific illustrator to show the color of a healthy coral with its algal symbionts compared to a few branches that had started to bleach. And here's a fully white print of the same model. This was created through Shapeways, and they did a fabulous job. It looks like porcelain. We even created coral bronzes using these 3D models. And I really like the story of combining an old world art form of bronzing, which has been around for thousands of years, with modern day 3D printing methods. And in thinking of the possibilities of 3D printing corals in different materials led me to discover the similarity between coral reef structures and the way 3D printing is being used in architecture. I also realized that since coral animals create massive and complex geological structures by depositing calcium carbonate, perhaps they're the original 3D printers. And to play with this, our friend Ron Rael at UC Berkeley created a 3D coral print made out of calcium carbonate. So we're also working to digitize and share museum collections. We've been partnering with the California Academy of Sciences in San Francisco, which, like the museums of the Smithsonian, is an incredible conduit between research and public education. And we are creating 3D models of the Academy's coral specimen collection for historical preservation, education, and research. Plus digitizing these collections make these treasures available to anyone who wants to view them. This one on the left here, this plate in Goniastria, was collected by Sylvia Earle in the 1970s at about 100 feet from a Japanese shipwreck. It's quite a story. And I'm pleased to say that we're beginning a partnership with a 3D program here at the Smithsonian with the Digitization Program Office to digitize and curate coral reef specimens from the Smithsonian Museum of Natural History collections. And what's so exciting is we're not just doing coral animals, we're also working on the incredible biodiversity that live on a coral reef. And we'll be overlaying these models with curriculum and stories. One of the big highlights for me when I've been hanging out with Tim Coffer in the collections was seeing all of these specimens collected by someone named James Dana, who's basically the American version of Charles Darwin, that were collected in the 1800s. I mean, around the same time, President Lincoln was saving Yosemite. So another potential use of these models, in addition to having interactive websites, is augmented reality, where you can place the model in your real world. So I've been playing around with the platform, the AR platform through Sketchfab, and here's my coral and coffee from the other day. And I've also been placing corals around town this week. And augmented reality is a great opportunity to bring coral reefs into public spaces and into people's consideration. So regarding our collection in the wild, the Hydrous has led expeditions to a number of places around the world to collect our content. Our flagship location, which we go every year, is the Maldives, which is an island nation in the Indian Ocean, made up of about 1,000 individual islands. And this country is on the front lines of climate change. As sea levels rise, the islands are disappearing before our eyes. Most of this country's land sits less than a meter above sea level. And the highest point is about 2.5 meters, which is about 8 feet. And the Maldives also rely on their coral reefs. Fishing and tourism support the country's economy, and the Hydrous has been traveling there for the last 3 years. This is one of our local ambassadors named Pachi, who's a fisherman from the northern Maldives. And was swimming over a healthy reef. You see this golden brown color. And indeed, when we were there in 2015, we saw all of these beautiful, thriving coral reefs. And I think you know where this is going. And this particular type of coral here is a tabletop acropora, or acropora, which is known as one of the most thermally vulnerable coral genera, and they were ubiquitous in 2015. Unfortunately, in April and May of 2016, the mass bleaching hit the Maldives, and about 60 to 70% of Maldivian reefs bleached. So when we went back in December of that year, we saw a lot of dead corals, which looked like stone, and it was like viewing the ruins of a once great city. So on our expedition, we had a really great team, 19 participants representing 13 different countries, made up of scientists, divers, designers, filmmakers, and technologists. We led workshops and learned about local issues from our Maldivian partners. We collected 3D models as well as virtual reality footage. And we also had an opportunity to conduct surveys to monitor the health of the coral reefs following this major disturbance. One of the projects on the expedition was therefore to conduct traditional standardized surveys to measure post-bleaching mortality using an accessible protocol. And these data were contributed to scientists both in the Maldives and abroad to add to their growing long-term data sets. And here I am with my PVC pipe and underwater paper, and maybe this seems a little primitive since I'm talking about digitization, but I'd like to point out that while it's important to innovate and use new technologies, it's also wise to incorporate and build upon proven and established methods that are part of the universal language in order to understand and solve problems. And on our upcoming expedition, we're partnering with ReefCheck, which is the gold standard for citizen science in the ocean. And with the local Maldivian ReefCheck chapter, we'll train participants in monitoring techniques to become citizen scientists and ocean ambassadors. So after noticing a lot of the dead coral and the eroding coastlines of the islands we visited, 2 participants on our last expedition had the great idea of 3D modeling islands using their drones. So here's a model of Pineapple Island. There were no pineapples on it, we looked. And notice the dark brown around the outside, that's all dead coral. And here's the mesh underlay to prove it's a model and not a movie. So this type of visualization has incredible potential for long-term, large-scale monitoring from a different perspective. I also like that on Hydrous expeditions, we began by modeling coral colonies, and now people on board are modeling entire islands. And we'll be scaling up in this direction. And our goal is to digitize the Maldives by combining aerial drone footage with in situ benthic habitat data and our large reef swath 3D models. And by the way, we have a few spots on our upcoming expedition if anyone is interested in joining us. So we also collect 360 content on these trips. And you've probably noticed an explosion in VR technologies for all sorts of cool applications. And at the Hydrous, we're embracing VR as a new and promising mode of storytelling and learning. And we're very excited about early research into the use of VR for education that suggests that using VR may be more effective than traditional methods to teach and generate empathy for environmental issues. And plus, oceans and virtual reality, I mean, it's like a match made in heaven. You know, it's an immersive experience, and trying to replicate what it's like to go diving is amazing what we can do now. So through our partnerships, we're bringing our 360 content into classrooms and onto public platforms. Here's a still photosphere of a manta ray cleaning station in the Maldives. We collected this by taking multiple photos and stitching it together using the same methods pioneered by Google in the Catlin Seaview survey. And here's one taken among some dead corals. And all of these photospheres are publicly available from the free apps, Street View and Google Expeditions. So if you have a smartphone, you can view it. Even better if you have a little VR viewer, including a Google Cardboard. And something that's interesting is within just a few months of posting these photospheres, we had millions of views. And it's such an easy platform to use. So we're currently producing live action, 360, immersive, and interactive film. And this doesn't do justice to what we're envisioning, so I actually have my VR headset if anyone wants a proper demo later this evening or tomorrow. And so this film, we plan to share it in classrooms, at film festivals, at conferences, and on online platforms. And we'll primarily be filming in Palau, which is known as one of the bright spots of coral reefs, where reefs are doing much better than expected and better than a lot of other parts of the world. And so we want to speak to the ambassadors and the stewards in Palau and generate more ocean optimism about what we can do to protect these spaces. So these are the ways we're working to generate human connection to our ocean. And it's been such fun and fulfilling work. In my work as a postdoc and a PhD student, I didn't think I'd be talking with designers and artists and teachers every day. And it certainly takes a village. I'd like to acknowledge our partners and our collaborators. And I am very proud of the dedicated multidisciplinary team we have. And to revisit my Yosemite analogy, this is what the agents of positive change in our oceans look like today. We have more tools and opportunities than ever before for creation, for connection, distribution, and mobilization. We can reverse the degradation in our oceans if we use these tools, make good evidence-based decisions, and work together. So let me wrap up with one of my favorite quotes by Senegalese environmentalist and forestry engineer, Baba Diem. In the end, we will conserve only what we love, we will love only what we understand, and we will understand only what we are taught. And to add to that, I would like to say that we can only learn about, understand, and love the things we see and feel. And that's at the heart of what we're doing at the Hydrous. Thank you. I understand there's time for questions.
Thanks for the talk, and it was really visually beautiful, and my question is about that. So, unlike the sort of pristine 19th century paintings of these environmentally healthy environments, the bleached corals are ironically just as beautiful in a certain sense as the healthy corals, and particularly those 3D printed corals look very kind of mod coffee table book. I don't know. So how do you expect to communicate the sort of urgency of the issues, and what are you finding when people interact with these reproductions of the corals? How are people impacted by them that you're observing so far?
Well, it is indeed a beautiful death. Coral bleaching is quite gorgeous when it turns white, and sometimes they bioluminesce in all sorts of colors. I recommend watching the film Chasing Coral if you haven't already to learn more about it. And I would have to say that by having these objects and having these VR experiences, people's reaction is one of great curiosity and interest. And even on the basic level, explaining what coral bleaching is and what a living coral looks like versus a dead coral versus a bleached coral is something that you really need that visual aid for. And something I found incredibly surprising on last year's expedition to the Maldives when we came upon all of this dead coral. On our first dive, I remember crying into my mask a little bit because it was so obviously devastating. But then we come out back onto the boat, and most of the other participants who aren't coral biologists were just talking about the turtle they saw and thinking it was a really nice dive. And even people that have had hundreds or even thousands of dives may not even know what a dead coral looks like. And that comes back to this idea of shifting baselines, where we have such a short collective memory that what we grow up with or what we see and think is normal, it just keeps sliding down. So my hope is that through this curation and curriculum that we develop that accompany these models, we can help explain that and really use that curiosity that these objects and these stories generate to answer those questions. All right. Oh.
I'm curious, as someone who's really interested in science outreach and science communications and science literacy, I think of what you're doing is absolutely fantastic, and I think being able to have that immersive experience really drives it home for people. But you mentioned at the start all of these various different factors that are playing into this coral bleaching and the death of the oceans. Do you have any thoughts on how, whether for the oceans or other aspects of science or climate change or however, to get that to the groups that can actually really make change? If for overfishing, somebody would say, okay, well, great, but I have to make a living. How do you, I guess I'm trying to think about how do you get it beyond just education and get it to the
Well, just for that example,
the problem.
for that example of overfishing versus the livelihoods of fishermen, there have been some really wonderful research showing that by not fishing in an area actually creates livelihoods. And a shark in the ocean is much more valuable than a fished shark, right? And so we have this economic argument that to support a lot of these cultures and a lot of these communities around the world, it's the best decision not just for the ocean to sustain, but for us to sustain. And it is a complicated and difficult question when you're trying to approach who to target. And the approach we're taking is that we ultimately believe in democracy, and we know that a lot of the changes that are coming about in a positive way are pushed through from public support. And so we need an informed populace, and we need people to make changes on their personal level, but also ask their government to do so as well.
Thank you. Yeah, I think you've made your argument a very sound argument for how you engage people in your cause. I think the way you do it is extremely powerful. But I think, like you said, it's a combination, if you want to really have impact in the work that you're doing, between, let's say, ground level support and political will. And I was curious about how do you try to convince political will to change to actually support what you're doing here? Do you have also do you get politicians into a diving suit and go down there?
Well, first of all, I'm really looking forward to seeing your playbook to figure out how to measure impact. And when we're talking about advocacy and visualizations, it's difficult to track that to real impact. And what we've decided as an organization is that we're sort of on the left in the advocacy value chain. We're mostly about engagement, but we give people the information to lead to political decisions, but we don't necessarily point to any particular piece of legislation or political party. And so we've decided to stay kind of unbiasedly scientific in that point of view, but even though these days being a scientist is political. But again, I would love to hear your advice on how we can measure that impact.
Closing information. First of all, every conference has its heroes, and I've thanked many of them at the opening this morning, but I have some new heroes to thank as I close. And those were the people who stepped up to substitute for us in the absence of a couple of speakers. So Liz Neely, who I don't know if she's here or not, but thank you very much for stepping up for John Hessler at a moment's notice. Also Diana Marsh and Rob Leopold, my new hero, for finding Diana for us. So thank you very much. And I would just like to thank all the speakers today and all of you for your comments and for your participation. Thank you. We'll see you tomorrow. We start at 9 again. Thank you.